Hello and welcome to part 5 of the UBIK solution. Today we're going to talk a little bit about theory and the structure of how we're going to build this. So there are going to be some minor changes to the code only. If we open up the README file, you can see here we have a link to the thesis paper by Matthias Parcher. And if we open that up and turn to page 8, we have the first part here. It's called the shoulder pose estimation. And what he talks about here is how you can estimate whether you are looking down and how you want to place the neck bone and stuff like that. And this is an area I want to address now because I actually deviated from his solution on that matter here. The reason for that was that I decided not to try and estimate the neck bone itself because it doesn't really seem to make that much of a difference. But instead I focused on what we call the spine 3 bone of the skeletal mesh, which I'm going to get into more in a bit. If we scroll down a little bit further, he mentions how he orient the yaw of the upper body by taking the weighted or the mean between the shoulder bone, which is actually underneath the head, and pay attention to the term shoulder bone or shoulder, because that's the term that he used throughout this paper here. The shoulder is actually not on the sides out here. It was something that confused me a little bit to begin with. What is out here is actually the upper arms. So just a little thing to note. So if you look at the logic here, he's pointing out, he says it's going to be, if we have this as a left hand and this is a right hand, and you have the head position, then the chest orientation is going to be these two vectors added from the normalized versions. All this is described in the paper. So again, this is again something I deviated a little bit from because I didn't really like the result I got out of it. So you could decide to just follow his implementation, or you could just follow along with mine. So if we continue down a little bit, the next part is going to be a bunch of trigonometry, and that is specifically how you can calculate a bone or the elbow joint, and that is explained here by using the cosine rule. We will get more into detail with that later on, but you should definitely get acquainted with that if you're not familiar with it already. That is the two main parts of the implementation, and actually the third has to do with how we rotate that elbow joint here, because the elbow is the elbow will be placed in kind of like a plane between the hand and the shoulder or the upper arm, and that means there's going to be kind of a plane here. So, but in space, that point can actually be in an arbitrary place in a circular form. So that is the trick, really, to figure out where to position that elbow joint. Towards down here at page 18, you can see how their logic works. Again, I deviated a little bit from it and do it a bit differently. So you can still use this paper here to figure out what happens, but just pay attention to the fact that I deviated from this part here. The rest of the paper is mainly some tests that they did and some measurements and comparisons. So let's go back to the code itself. You should be having, let's see, where is it? You should be on the UBIK part 5 commit here. So make sure you are on that. And then you can open up the project. So if you remember from last time, we created these small debug helper things, and we also have the debug draw functions, which I actually, I think I disabled them in the meantime. Yeah, it seems so. So if we just hook that up again, we see we get the axes drawn out. Okay. So let's start off by creating the skeleton for the implementation. It's going to work off the tick in the UBIK component. And from the sequence here we left off last time, we're going to create a, for now, a reroute node. But we're going to create a function called set shoulder. And then we're going to call it. And we are actually gonna do a few things more to begin with. I just forgot. Let's just move this down. Let's see. Like this. So we're also gonna make a function called set or convert transforms. So if you remember, the head effector is in world space, and all these transforms here, really, they are in world space. And we need to convert them into, to begin with, component space, and then later on we may need to convert it again. So there are going to be quite a few places where we convert into different spaces. And in a way, the first conversion is going to happen here. Like this. And then we're going to set the shoulder, and then finally we're going to solve the arms. So let's create a function called solve arms. So this is just to get an idea of how this is going to be structured. We may probably, or we probably will make some changes to it later on, but this should, yeah, give a good idea about how it's going to be. What we should also do here is to convert, or we could, let's make a function out of this. Right click, convert to function, like this, debug draw. And we could make a variable, draw. Okay. Okay, so when we hit play, we don't have any debug on, but we can change this setting here, and then we have the debugs on again. Okay, right. So I guess that is the main thing I wanted to share in this video here. We could do one more thing. We could do the conversions here. It's not that complicated anyway. We just need one more thing here. We need the component transform. And by component, I don't mean the UBIK component itself. I mean the skeletal mesh that we will end up with showing this on. So it's going to be this mesh here. So we should transform or make sure that it is set on this get transforms. If you remember this huge one we made in, I think it was episode part 3 or something. We should add another pin here. Just make sure here to transfer the mesh component here. Get world transform and then transfer that onto our UBIK. I forgot to create it. And again we say component mesh and skeletal mesh component transform in space. There we go. So now we have the mesh transform in wall space set on the UBIK. That means that now we have the components, the parts that we need in order to convert these transforms into ComponentSpace. So I'm going to create a duplicate of this one called head effector. You know what? Yeah, I'm gonna append comp at the end. I haven't really done it this way when I did it the first time, so to be honest, I'm not really sure this is the best way, so I might change it later on. Anyway, so I'm gonna do the same with this one. And with this one. Okay, so the conversion happens by taking this component transform, which is in world space, invert that. That will give us the world to local, and then we compose this with if I'm not mistaken, it needs to be the other way around, like this, and take the head, the head effector, which is the world location, and then convert that to set this into the head effector comp. And then we're going to do the same for the two hands. I'm going to create a local variable for this. Comp trans this. Oops. Let's switch out this one and switch out this one. So we can't drag onto the set. I think for some reason it crashes. So I'm not gonna try because I'm recording, but yeah, you might want to try yourself because it's a little bit faster to do it that way. Okay, so now we have the transforms converted and we have them ready to be set up on the function setShelter, which is what we're going to continue with next. We have a compiler warning. Okay, there we go. So there's not much to show at the moment, but these changes are definitely what we're going to need in here. So we can start to work on setShelter next time. So with that said, thank you for watching, and I will be seeing you in the next. Bye.